Good morning, good afternoon, good evening, whenever and wherever you are. My name is Anna Rochelle, and today we are going to do an Algebra 2 review sheet sent in by a student. This is kind of like a spiral review. I can't really quite say like, oh, all of these problems are from a specific chapter, but they're mostly Algebra 2, either first or second semester. So this might be a good review to do when you're studying for a final exam in semester 2, because some of these things came up in semester 2. Okay, so most of the instructions are simplify, and I didn't realize that. So I just wrote simplify for pretty much every single problem. Go me. Okay, so we are looking for the fifth root in case that's a weird looking number. It's supposed to be little in the radical, right? It's the index. So I want to know how many groups of five of the same exact thing do I get with this negative 64, x to the 13th, y to the 7th, z to the 10th. So I know z to the 10th is going to have two whole groups of z. So I'm going to go ahead and I'm going to pull out z squared. I know y to the 7th is only going to have one of these y's, and then another will stay in the radical. I also know that x to the 13th will have two x's that'll stay out and three that will stay in because I'm going to have two groups of x. Essentially, what's happening is you're looking at 1, 2, 3, 4, 5 x's, then 1, 2, 3, 4, 5, and then 1, 2, 3. So this is 13 x's. This is one group of five that can be pulled out of the radical. I have another group of five that can also be pulled out of the radical. And then I have this three left over that's kind of like can't be pulled out. It doesn't have a group of five. It's still missing some. So this three is still going to stay in the radical. Because I have two groups, I'm going to end up with x to the second power. Negative 64 actually is negative 2 times negative 2 times negative 2, 5 times. So I'm going to pull this negative 2 out, and I'm going to multiply it by the 2 that's already out here. So my final answer, just to clean this up a little bit, is going to end up being negative 4 because I'm multiplying this. X to the second y, z squared, fifth root of x to the third y. Final answer. We always want to make sure that it's fully simplified and then it's cleaned up a little bit. Like there's no reason for this empty space here. Okay. When we're asked to simplify something like this, I would actually say this is called rationalize the denominator. So rationalize the denominator, denominator. And when we rationalize the denominator, we're going to take this denominator and actually multiply both numerator and denominator by the flipped, I guess, or flipped is not the best word, but it's the best word that I can think of right now because sometimes words are harder than numbers. Okay. And we're going to multiply it by the flipped. We're going to use flipped. We're just going with it. Okay. Instead of subtracting two, we're going to do add two. And we're going to multiply both numerator and denominator by exactly the same thing. Because if I multiply a fraction like one, let's say, for example, 2 over 3, if I multiply this by 4 over 4, I'm essentially multiplying it by like a really big 1, right? And then I'm going to end up with 8 over 12, which is still the same exact fraction as 2/3. So that's what gives me the possibility or the opportunity that I can multiply both numerator and denominator by the same exact fraction, right? By the same exact top and bottom, so that my fraction, my original problem doesn't change. So I know that this is going to be in parentheses, right? And this is also going to be in parentheses. So the numerator is just simple. We're just distributing, right? And then we're going to combine everything that we can if we have additional terms that we can multiply by or that we can combine. So my top is going to just be 5 root 7 plus 10. My bottom, on the other hand, I'm going to do multiple distribution, which is, you might have heard it as FOIL. So I'm going to end up with regular 7 or root 49, right? Plus 2 root 7, minus 2 root 7, and then minus 4. Now, the beauty about this is actually called the difference of two squares. You might remember it because you've seen something like x squared minus 9. And when you factor it, you go in and you see x minus 3x plus 3. So something like that will show up where you have the same first and second term. It's just one is plus, one is minus. When we do have that difference of two squares, the center kind of like cancels itself out because I have a positive and a negative, right? And so really, if I were to clean this up, I'm going to go 10 plus 5 root 7, because we always want this kind of like in this a plus bi format, and I is your imaginary number, which is the square root, right? Over 7 minus 4, which is 3. So this would be my final answer. Now, the one thing I do want to make sure that you're careful with is actually distributing everything, right? Most times I'll see students go 5 root 7 plus 2. They won't distribute it fully. So just make sure that you're fully distributing. Okay. We know that the cube root of 64 should be 4, and the cube root of 27 should be 3. Now, these are all numbers that don't have any prime factors in common. So we know we're not going to be able to simplify that. So we're just going to end up doing 7 times 4 over 5 times 3. So you're taking like individual pieces of the problem, solving it first, and then combining it all together. So I'm going to get 28 over 35. Final answer, and I can't simplify it any further. This is another type of problem that's similar to question 2. I want to make sure that we know that this squared just means that I have 2 of exactly the same type of set of parentheses, okay? Gosh, words are really hard today. So I know that I need to do multiple distribution. I need to do FOIL, so I'm going to do that. I'm going to go 2 times 2 is 4. 2 times negative root 5 is going to be negative 2 root 5. Then I have negative root 5 times 2 is again negative root 5. Then negative root 5 times negative root 5. So negative times negative is positive. And root 5 times root 5 is actually 25, which can be replaced with 5. So I'm just going to go ahead and like continue to clean up or simplify, I guess we can say, as I move further and further down in my problem. So I'm going to end up 4 plus 5 is 9. And then these guys are the same terms. So I'm going to go 9 minus 4 root 5. And here we are. Final answer, fully simplified. I can't simplify anymore. I don't have to rationalize any denominators because I don't have any denominators, which is really nice. And I have to be honest, when I saw this problem, my heart just got so full. And I was like, oh my gosh, I love these problems. They're literally the best. Like, this is what I dream about when I dream about doing math. So here's what we're doing. When we solve a problem like this, our ideal goal is to factor everything first and then go ahead and cancel out whatever is the same. So I'm going to go ahead and I'm going to set up 2 big fancy pants fractions. And I'm going to start with the most basic one for me, okay? Let's say you're looking at this problem and you're like, oh my gosh, this is super easy. Go for it. I'm looking at this and I'm like, I know 15 is 3 times 5. And I know if I have to have a negative, I could just make it negative 3 times positive 5. And those 2 numbers will add up to 2. So that makes my life super simple because now I know that some other, one of the other quadratics is going to have either one of these in its parentheses. Okay. So then I know this one, 18, is actually a negative 3 times 6. Again, see how that negative 3 shows up? So I'm going to go x minus 3, x plus 6. And again, 6 minus 3 is regular positive 3, so it works out nicely. Because this one I see is negative 3, I know right away I'm going to have an x minus 3 in here. The other option is going to have to be something with the 8, right? Now, if I do 8x plus 1, which will give me this negative 3 that I'm looking for, I will not get what I need with regard to 10x. So I'm going to have to go ahead and start all over again and really think about it. I know my factors of -3 are just 1 and 3, you know, and my factors of 8 are 4 and 2 and 1 and 8. If I were to multiply 6, 2 times 3 is 6, plus 4 times 1 is 4. So 6 plus 8 is, sorry, 6 plus 4 is 10. Holy cow, words are really hard. I don't know what's happening. I do go in depth in how to factor something like this in my factoring set of lessons. So I'll definitely link that video in the description so that you can go back and see those videos as well. So I know I'm going to go in, I'm going to have 2x times 4x. And then, so 2 times 4 is 8, and then 3. So I want the 3 to multiply with the 2. And then, actually, no, I want the 3 to multiply with the 4, because then this is going to give me positive 12x, negative 2x, and that's going to give me my positive 10. Yes, that's exactly what I want. Okay. So then for 5, I have 1 and 5, and for 4, I have 1 and 4 and 2 and 2. And I need to somehow create 19, but I need a negative. So I know I'm going to have these bits here. So I'm going to end up with 4x times x to get 4x squared. And then I want the 5 times the 4 to get 20, and then minus 1. So then this will give me negative 1x and positive 20x. Beautiful. And then together it'll add up to 19. Amazing. So now I'm going to go ahead, I'm going to do a different color, and now I can simplify things. So this and this is the same, it's fully simplified. This and this is also the same, fully simplified. That is it. That's all I can simplify, because in the numerator, I have this x plus 5 squared. And in the denominator, I have 2x plus 3 times x plus 6. There is nothing else I can do with this. Now, I've seen in the past some teachers not like it this way. I've seen in the past teachers like it where it's written out x plus 5 and x plus 5. I've seen also in the past where teachers say like, oh no, you need to FOIL this out. You need to make it into x squared plus 10x plus 25. I mean, there's lots of different ways. I would just pay attention to what your teacher is looking for so that you can give your teacher what they want on the homework assignment or the test. Okay. So now when we're here, we know that we need to add and subtract. And in order to add and subtract fractions, we need common denominators. In order for us to have common denominators, I need to factor this first into x plus 7, x minus 7. That's a weird looking x. And then I see that, hey, all of my terms have at least an x plus 7 or at least an x minus 7. So I'm going to multiply this entire fraction by x minus 7 over x minus 7 so that my denominator has both of them. And this fraction I'm going to multiply by x plus 7 over x plus 7. Oops, that's a weird looking parentheses. So that way, again, my fraction stays the same. It's not really changing. It's just getting bigger numbers in the numerator and denominator. So I'm going to end up with x plus 3 over my two sets of parentheses. This x, that is not a plus. X minus 7 minus 2x minus, nope, I don't want to do that. Actually, I have a better plan. I want to show you something. And then plus 3 and then x plus 7 over both of these. I'm going to essentially cross off this bottom piece for a hot second because I don't need it. In fact, I'm going to like lift up these addition and subtraction signs so that I have kind of like one whole, just the numerator. Because I know once all three denominators are the same, essentially the whole entire fraction is above that whole piece. So then I know that I'm going to take this -2 and I'm going to distribute it to each of these terms, and I'm going to take this +3 and distribute it to each of these terms. So I'm going to end up with x plus 3 minus 2x plus 14 plus 3x plus 21. And now I can go ahead and combine like terms. So I've got 4x minus 2x is 2x. And then 3, 14, and 21. So that's going to be what? 35, 38. I can go ahead and just factor out a 2 because they're both even, but honestly, I'm not even going to bother because I know nothing will change in the denominator. I won't be able to simplify any more than I already have. So we're looking at this kind of final solution. Again, I want to make sure that you're careful with this negative sign, that you're distributing a full -2 to everything. I kind of made that mistake a little bit really quickly when I was moving fast. The first time I did it, but I would not, I wouldn't think that, I feel like that's where students mess up the most, is forgetting to distribute fully, forgetting to distribute a negative fully. That's kind of like a typical error. So if you're doing problems like this in your class right now, definitely slow down and take a step and think about it before you do the solution. Okay. We are looking for a horizontal asymptote of this function. Now, we know horizontal lines look like this and vertical lines look like this. Now, the one thing that we also know is that vertical lines have an x equals some sort of number, and horizontal lines have a y equals some sort of number. So I know that my final solution is going to be y equals whatever the number is, right? So with that being the case, I now need to not set this equal to 0 because that's going to give me a vertical asymptote, okay? Because then I'm going to end up with x equals something, right? Instead, what I'm going to do is I'm going to take the ratio of my first two of my coefficients, of my leading coefficients. The reason why I do this is because the reason why I'm allowed to do this in this particular case is because both of my exponents are the same. If my exponents were different, it would be a completely different problem. But because both of my exponents are the same, I can simply take the coefficients of the leading coefficients, right? And set them equal to y. So 7/8 equals y, or y equals 7/8 is my horizontal asymptote. Okay, so now we're going to go ahead and find all the zeros. And that number 9 is similar. We're going to factor completely. In this case, I am a fan of just taking a look and saying, okay, I know that x to the 4th is just x times x to the 3rd, or x squared times x squared. If I, for some reason, think that this would be a good choice, I will be wrong. Here's why. Eventually, after I FOIL things out, after I factor things out, I will want to check to make sure that my answer is correct, right? In order to make sure that my answer is correct, I need to FOIL things out in my two sets of parentheses. For example, in here, in these two problems, actually, I factored out what I needed, and then I did the inner and the outer kind of FOIL, kind of to see like, hey, am I getting the right number in the middle here? Okay. In order for me to go in and say, hey, I'm going to choose x to the first, x to the third, I will never end up with x squared. It won't happen. So this will never be an issue for me. I will never choose that ever, ever, ever in my life. Okay. That being said, I'm going to open up two sets of parentheses and I'm going to set up x squared times x squared, which gives me x to the 4th. So I'm good in this department. When it comes to 100, my factors of 100, and I'm going to write those here: 1 times 100, 2 times 50, 4 times 25. Oh, look, this is kind of where we're at. Because I'm looking for minus 100, I know one of these is going to be negative. I'm going to assume it'll be -4 because I want a +21. So I'm going to go -4 plus 25. Now, they say find all the zeros. In here, I know that x squared minus 4, I can set that equal to 0. Minus 4, I can set that equal to 0. I'll end up with x squared equals 4, and then I'll square root both. I'm going to end up with x is both positive and negative 2. When I set this equal to 0, x squared plus 25 equals 0, I'm going to end up with subtracting 25 on both sides. That's going to give me x squared as negative 25. I can't take a square root of negative. It's going to have to be imaginary. So x will be both positive and negative 5i. And this is why I think, like, because I know the zeros end up in second semester, but the imaginary numbers end up in first semester. So I can't really quite say, like, oh, this is all first semester, this is all second semester, because math builds, right? Okay, next, factor. I know that this is a cubic function. And I always forget this. I think it's SOAP is the mnemonic. Whenever I have either the sum or difference of cubes, so this is a perfect cube, this is a perfect cube, this is a perfect cube, and I have the sum of cubes, I know that in order to factor this, I'm going to take my first term, which is going to be 10x, and then I'm going to take my second term, which is going to be 1. And I'm going to factor this out in kind of a slightly different way. So I'm going to have a plus or minus b, and then a squared. So this squared, and then this b will be also squared, and then this will be just ab. So 10x times 1. That is like, that does not look beautiful at all. We're gonna try this again. So I have 10x squared, and then I have 10x times 1, and then I have 1 squared. So this is essentially where I'm going, hold on. Like this is my very large parenthesis, and then everything here is like fully squared, right? This is my large set of parentheses, and everything there is not squared. In order for me to remember what my signs are, because that's always been the bane of my existence ever since I learned positives and negatives in 7th grade. In order to figure that out, somebody said there's a mnemonic called SOAP. So same, and then opposite, and then always. So AP stands for always positive. And here's why I liked it so much, is because I remember soap, because I like washing my hands and I like being clean. But it's referring to this sign here. Okay. So my first sign in this entire fully factored problem, I'm going to end up with same plus. Opposite of plus, subtract. And this will always be positive. So my final answer, just to clean this up a little bit, is going to be 10x plus 1, 100x squared, because this squared applies not just to the x, but to the 10 also, minus 10x, because, hey, times 1, and then plus 1. This would be my final answer. Okay, I hope that this was helpful. And then I have my last one, which is write the equation in slope-intercept form, assuming that the line passes through these 2 points. This seems to be a problem that the student who sent this in to me is consistently struggling with. And I wanted to really talk about this a little bit, just so that we can understand what's happening. We've got a disgusting fraction point. No one likes it. I'm not oblivious to the universe, and I know I'm the only crazy one who likes fractions and thinks fractions are fun. Totally fine, not offended in any way, shape, or form. However, I know that when students see fractions, they automatically buckle at the knees and don't want to do the problem and end up making a mistake somewhere. So our job is to, what I like to call, bust the fractions. Our job is to bust these fractions, to like karate chop them out of our life, right? The best way that I know how to do this is to multiply each of these um, portions of the coordinate point by the common denominator, the largest common denominator, so that I can eliminate that common denominator or that denominator in general. I'm going to multiply each of these by 4. So here's what's going to happen. 0 times 4, that's just going to be 0. Negative 3 times 4 is going to be negative 12. But then here I'm going to have 3 over 4 times 4 over 1, and these 4s will cancel. So I'm going to be left with 3. And then I'm going to take 1/2 of 4 over 1. This will cancel and become 2. So that'll be 2. So now I have these new points to create my my slope, to find the slope. Because imagine putting into your slope equation a fraction in for x and a fraction in for y. I think it's just going to be a little bit crazy. So I'm going to call this my first point, this my second point. So I'm going to go 2 minus negative 12, which is 2 plus 12, over 3 minus 0. So I'm going to end up with 14 over 3. And we want to leave this as the slope. But because they're saying write the equation in slope-intercept form, so slope-intercept form is just your standard y equals mx plus b. So we need a slope and we need a y-intercept, okay? What's really nice about this particular question is that you can just take this point and say, hey, that's my y-intercept. So I'm going to end up with y equals 14 over 3, x minus 3. And that's going to be my final equation. Because this is my y-intercept, because they're telling me I move left, right, 0 and down 3 on my y-axis, I know this is my y-intercept. I don't have to go any further. I don't have to do a lot more math. I hope that this was helpful, and I will see you in another video. Bye.